Yeah, so you can see that this is the traceability matrix. So its traceability matrix is the document that correlates any two baseline documents, many to many relationships. So it is your document, your map tracing the user requirement. So you're checking for all requirement by the client and requirement in a single document. And the main purpose of requirement traceability matrix is to validate all the requirement for checked via test cases. So basically it is important to get all the requirements. To achieve this goal, every QA should understand the requirement thoroughly and create positive and negative test cases. So a question arises whether or not to make sure that the requirement is tested considering all possible scenarios or cases. Simple way to trace a requirement is requirement traceability matrix. So these are the parameters you need to include. One is the requirement ID, the other is the requirement type and description. You can see here is the description, here is the test cases, and the status, did it pass or did it fail. And you can open this and you can see that this is the description. Log into the application. This is the first test case. Log in with invalid username and valid password, and you can see completed, what happened with it. Did it pass, this one passed, this one passed. You log in with the valid username and invalid password, log in with valid credentials. So you're checking for all the positive and negative. This one is a negative, this one is a positive. So you can see they're checking for everything. And the requirement can show that the requirement coverage in the number of test cases. So you design status as well as execution status for the specific test case. This kind of matrix would be provided one-stop shop. So here we have forward traceability. It means the requirement is applied to the product and each requirement is tested thoroughly. Backward is that we are not expanding scope of the project by adding code and design element, test, or other work that is not specified in the requirement. So you want to make sure everything's on the right track. You can do both directions, make sure the requirement is covered by the test cases. You can go to this guru99.com/traceabilitymatrix.html to see what's going on. Another thing is this other website, guru99/testcases.html. So here they tell you, best practices for using a good test case. So it needs to be simple and transparent. You need to create a test case with the end user in mind. So basically make sure the user is able to understand, meet all the requirements, avoid test case repetition. So don't put more than one, and do not assume. You can ensure 100% coverage. So however, 100% coverage, traceability matrix to ensure no function/conditions is left untested. And implement testing strategies. Software testing helps you select a few test cases with the maximum possibility of finding a defect. So you can do, all this stuff. Boundary value analysis, testing the boundary range of value. Range, like you're checking, is it 6-digit number password versus a 9-digit number. If you put a $sign, what happens? Does it take it or does it not? Does it take uh, other characters, 1 to 5 versus hashtag, all those characters, which one is okay, which one is not? And the test case should be generate the same result every time. And the test case management tool, so we can use for documenting, we can use test cases. execute the test case, automate the defect. We can automate it if we use the bug tracker stuff. We can track it by email notification. Traceability is the execution of test cases, and naming, versioning, control, offsite backup. So if you can go back into this thing, traceability metrics, you can see here they are showing, you put in this or no technical requirement, verify login, this is what you tested, the data, this is what you got, result, login successful. Traceability, verify login, go to login screen, enter user ID, enter password, enter login, all this stuff you put in the test data, guru 99, password 1234, login successful. So all this stuff you can put in. Business requirement, you can put B1, B2, B3 technical requirements, status ID. So this you're doing in the test suite. When you create it, you can follow it by doing all this B1. You can give it some numbers so it remembers what test suite you have. The advantage is that it confirms 100% test coverage. Any requirement is missing, it finds out. Overall defect will focus on business requirement, and you help to analyze and estimate the impact on QA team, that kind of stuff. You can also watch this video here as an example how to create the traceability metrics. Then you have test data generation. It is input given to the software program. Input produces the expected result. Poor design testing data may not test all possible test scenarios, which will hamper the quality of the software. So test data can be generated manually. Mass copy of data from production to testing environment. So testing environment. Mass copy of test data from legacy client system. Many test data take test my configuration. So white box testing is able to cover as many branches as possible, generated all the branches. Part testing, tested at least once. So we have negative API testing, invalid argument type used to call different methods. Testing data may consist of invalid combination of argument which are used to call the program method. So this is negative API testing. You can go inside API testing, it will tell you what is API testing, check functionality of APIs, you create something, business layer, presentation layer, database layer, API, how it works. You can click on here, it will give you some information. Business layer is, all the user interface, like what is the functionality I am creating. I'm going to do this. This is the function. I made a name. I made a customer. I made a person. And database, the database side of things, the SQL server, where all the data is stored. So that's the database layer. Presentation layer is the user interface. So that's where you enter all the information on the screen and stuff. So all of this is APIs. You can study more if you go in here. And test data for security services. Security testing is a process that determines if an information system protects data from malicious intent. So you can do integrity of the data, authentication, you check authorization, are the right people able to enter the data, or are they the manager is able to log in versus somebody else is able to log in. So this all test data for black box testing. The black box testing, the code is not visible tester. Your functional testing can have test data meeting following characters. So valid data invalidate a boundary, check the boundary values, are they beginning to end, what is the boundary, if you hit in a cricket, you need to know how far you can hit, so you want to check all the boundary values for the thing. And you can also do decision table data set, uh, decision table, state transition test data set, test data meeting your state transition, user case test. So all of this you can study, test generation, test data generation by app can be used to almost any database. It enables user to complete application testing by inflating a database meaningful data, protect data privacy by creating a clone of the existing value. And there's data test data generator, you can view procedure for all this stuff, QA testing, load testing, usability testing. So you need to know what all these things are. Performance testing. So this is given to me by DK Sharma. So you can see that this is how things are happening in the company. Company, they first sit down and they decide what testing to do. So here they're doing, they're going to use create test cases. We're using Jira, organize test cases in the suite, perform tests, create manage defects, trigger test, and then you can build it in the Power BI. Power BI is like nice where you can show the data like this. And then with all the data nicely, you can see people are able to show all the data. So you first, manual testing is taking place, functional testing, how much, automated now 60% people are doing that much work. So here you have the unit testing. Unit testing is, individual hardware or software components, which are also known as component testing. Unit testing is isolation from the rest of the system that wrote the code, sometimes based on risk, a peer developer, or a story level. So when as part of coding, elimination exposes defects using development. So you want to expose the defect. And then we have integration testing. This may include component integration plus functional testing. So testing performed to expose defect into interfaces and in the interaction between integrated component or system. So that's integration testing. Story level. So you want to go to story level, what's going on, databases, APIs, defect detection, validation, uh, true or false validation, you check for all the cases, positive, negative, and validation. You have system integration testing. It is to cues on the behavior and capabilities of the whole system or possible end-to-end which is available. Quality engines validate feature levels. So application software testing, configuration, all of this is under system testing. Defect detection. So you can see 40%, 25%, 10%. So this is the very last one, acceptance testing, respect to user, satisfied acceptance criteria, whether or not accepts the system. This is user acceptance testing when conducted by intended users. So it is, end stage development, business configuration, operation processes, system under test. So all of this. So these are different type of stuff you have to work on. Make sure you create all the test cases for all those cycles, test and defect management, like I told you about Jira. daily defect tracking process,